So in part one of this tower defense, we're going to build and construct our path that our creeps are going to be walking on, and we'll be able to turn them and have them automatically go along this path however you guys really want to design it. We'll be able to add in towers. Our towers won't be able to fire at the creeps quite yet, but that'll be saved for part two. But we'll have our money over here, and we'll go down by 50 every time we add in one of these towers. And as we can keep going, we'll have these towers fire, and these enemies will come in waves instead of just one at a time, and we'll keep going with our tower defense game. So I hope you guys enjoy and you get going with this video. So I'm going to open up a new scenario. Tower defense. And we can set our image. And I'm going to go ahead and make it this sand. That way we have these blocks, and we'll measure how big these are. And make sure they're pretty even down here so they don't get cut off, and we can use that as places along our tower defense line, so we can kind of draw ourselves a little maze here that we can use. And so if we open up our My World and change this, we can kind of count and guess about how much this is. This looks like a half, but we have 1, 2, 3, 4, 5, 6 and a half sets of pixels here. And so that's with 400. So if I just change to 600, we could see what that looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like they're 60 by 60 pixels. And so what that tells me is I can do a easy 10 by 10 grid by 60 by 60 pixels. Now what this allows us to do is, if we say we come in and we create, so here on opengameart.org I found another great 2D sprite, and so this tower grass actually will get you a tower in the grass that looks like this. So we can use that in our game, and that can be kind of our starter for our tower. So created by hasicf, and we can go into our and create a new subclass. We can call it tower. We can give the tower an image. And now when we plug it in, you'll see that it gets drugged to a specific spot and it snaps. So if I do tower, make it public, constructor, you can scale that to get image.scale, and we'll go 60 by 60. So that will make it the size of one of these blocks, and so you guys will be able to plug in those blocks at specific points. The next thing we can do is have maybe this X value extend a little bit further, and we can have maybe this side maybe 3 further, 3 or actually 4. Okay, and then we can have this side be an area to have our menu and pick our shop, pick our towers that we want to use. Okay, so if we create a new subclass of actor that is called menu, we can create a new image and just say gray, and have it be 60 by 60. So we fill that, make it gray. So what I've done is just created a gray box that I can use in paint and just make it a simple square. And then if you go in there and change this, because originally we don't know the size, look how huge this is, that's not what we want. We actually want it bigger, but let's just measure it to be about 4. So it's almost 4 blocks wide, 1, 2, 3, 4, and all the way down. So 600 would be the height of it. And so what we want to do is do public menu and draw this menu. So we can get image dot scale, and we want it 240 wide, be 4 blocks, and 600 tall. That way, when we add it in, it's the right width, but we're right in between on these. So now that we have our width and our height measured out, let's go ahead and change this back to 1 and multiply this by 600 and by 60, excuse me. So this would be, what, 840. Now, nothing on the surface changes, but we can put this tower anywhere we want, as well as this menu that I've measured out so that it is long enough and tall enough to fit perfectly right there. Okay, and so what I'm going to do, maybe bring that over just a bit. Yeah, maybe I'll put an outline on that or something later, just so we can see it a little bit clearer, but for now that'll do. So I'm going to go ahead and save the world, and this will create the prepare method, which I've done a whole bunch of different stuff to. I added in some towers and then I took them out. I added in the menu, so I'm going to take out the movement of the towers. I'm going to simply get my menu. So I'm going to move this into the exact middle, the exact spot I would like it. So the X value, if it's where it is right now, that'll be located right here, but we want it to be right there. And I can inspect that, and you guys can just use what I have here. And so my X value will be 722. I believe this will be better at 720, since it's from 840 is the very edge, 600 should be right on the left side, and so 720 and at 300 would make sense. So you're trying to split the difference here. So 720 and 300. And so now it's lined up pretty nice. We might need to make this a little bit taller. Not a problem. It really doesn't matter if it overlaps. So might as well do it. Now we want to make it so that these towers get placed only in this area, and only if it isn't part of a road. So we can do a few ways to do that. And so we can create a new subclass, call it road, and we could make a road, design our own road, or you can have them follow a road that they have here. This is their road. Let's see how it looks here. So if we added some of the road, we had it 60 by 60. This will work for creating our map. Okay, and so we'll design the map here in a second. But what we'd like to do is make the road also 60 by 60. Scale to 60 by 60. And then when I plug these in, it's the exact right size. But I don't have to line each one of these up perfectly. I want them to automatically snap in there or be able to draw it in some way. So in order to draw our map, we're going to need to create an array. And if you haven't done this before, and you haven't heard of creating arrays or multi-dimensional arrays, which is actually what we're going to be doing, I encourage you to go to a previous video. There's the platformer game that has done that, the platformer shooter game, excuse me, and also we've done it in the Frogger game. So if you want to go back and take a look at those, but here we're going to create something that is int map in brackets, so it's a multi-dimensional array, and basically we're going to have an array of arrays, and so it's going to be 6, 1, 2, 3, 4, 5, 6, and you need commas in between each index, and then a comma between each array within the array, each list of lists, right? So we can kind of copy and paste, 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 however many times we need to go down. What is that, 10 that we need to go down? Oops. And you'll see once you do a couple, you can just tab once and it'll line it up. Greenfoot knows what you're trying to do here. And so paste 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. There we go. Okay, and so you go ahead and get that lined up. There should be an extra curly bracket to encapsulate all of these. And we have the layout of our map, okay? And so our prepare method is obviously just storing the preparation of the game. And we're going to go ahead and call this level 1. And we can call it in as level 1 because we're going to start off at level 1 no matter what. And so level 1 should not hold the map, or the menu, excuse me. Level 1 should hold the rest of the map. And so in order to do that, we need to do loop through both of these arrays. And so for int I equals 0, I less than, let's go ahead and do 6 across, int I plus plus, and then 4, you can copy and paste this. That's what I like to do, and change this to a different letter, J. Oh, I guess these numbers are different, so 10. There we go. Now we're looping through the width of this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not 6, 10 by 10, so I should have the first one also be 10. Okay, and now we're going to, the menu's already going to be there, but we're going to be adding objects in, and so you can say if map. Again, I've done this in a previous video. If you want to learn more about it, I walk us through it a little bit slower. So if the location I and J, so it'll start off at 0, 0, meaning it's starting off in the upper left, and then J will move up, count up 1. But if it's 1, we're going to start putting a road down. Okay, so if it's 1, we're going to add object, new road. Now, as of right now, we don't need to specify the road, but we can change that later if we need to. So it'll add object, new road, and the location that it needs to add the object is based off of the scale. And so 60 by 60 times the distance at which they are. So let's say we just put 60 and 60. Let's take a look at what we did wrong. Out of bounds, the index is outside of the array. So it should be a 10 by 10 since that's the size. So I've actually messed up all of these. 3, 4. And now you can copy and fix my silly mistake here. And hopefully that doesn't take you too long. Keep pasting over. Alright, and this will give you a 1, 1, 1. So right now, since it's at X and Y of 60, 60, it won't give you, but it'll give you 3 of them. But we want to push it all the way up in the upper left corner. and this is not actually 0, 0. If we inspect this, it's actually 30, 30. And so our 0, 0, our very first should, if I was 0 and j was 0, it should still be at least at 30. So we're going to start off with 30 plus I, lowercase I, times 60, and 30 plus j times 60. So when j and I add up, they will start moving 60 over, and they'll be lined up with the blocks here, and it's going down when I meant for it to go up. And so our j should actually be first, and then our I value. This would be first the outer part of the array, and this would be the inner across the x value. That's why we have it here, and so that's why that's second. As first we're going inside the bigger array, and we're looking at the specific this array secondly, and that's why j is on the inner part of the loop and I is on the outer part of the loop, because the inner part of the loop happens first, where we go in, and then now you can see it goes across corresponding with the place we want it. So I can add a map here of my choosing, and I'm going to go ahead and do that now. Okay, so it looks like I've created a little bit too big of an array, so you need to manage that. Now we have our map here, and so we want to be able to place towers on the places along the map, and so we want to be able to click in towers, and so we're going to say add in towers. I'm going to public void add in towers, and we're going to say Greenfoot dot mouse clicked on anything. Say if Greenfoot mouse clicked. We're going to add more caveats to that, but for now we're going to add an object. What object? New tower. We'll change this up here in a bit, but new tower at location Greenfoot dot mouse info dot get x. So this will get the x value of the mouse, and Greenfoot dot mouse info dot get y. Greenfoot dot get mouse info. Greenfoot dot get mouse info. And this actually should be in the act method, not in the constructor. So we have to create an act method. Oopsies. And since this is going to be happening while the world is running, we're going to put the method in there. And then when we run, we can add in a whole bunch of towers. Now obviously we want the towers to be able to be placed in, and not be able to put in as many as we want. So, but it's getting, to a closer spot that we want it to be. And we also don't want to be able to do it on top of a road. Okay, and so we're gonna, since similar to how when we add something in at 0, 0, so if I ran it and I clicked all the way up here, this would be about 1, 1 or 0, 0. It should really be adding in an object right on into that block, so right there. So we'll try out times 60. So we can plus 30 to each of these, which is half the size of the image for the height and the width. So what that will do is move each of these out a bit, and when I run it and I click anywhere in here, it'll move to this exact spot. And now you can only, no matter where you click, mathematically, what it's doing is first it's dividing by 60. Division in Java will truncate if you have two integer values, and so that will round it down. So if you do any 0 to 60 or 59, it'll round that down, so that would be 0. So it would multiply 0 by 60, stay 0, and then add 30, and it would do the same thing. So anything I place between 0 and 59 will still be right there, but then once I hit 61 on the x value, 61 divided by 60 would be 1 point something. So it would round that down to just 1. 1 times 60 would move it over 60 pixels, plus the additional 30 that we added on at the end. That will put it right here. So if I'm even right there, it'll click into the correct spot. Here, here, lower corner. Basically, you have anything in this window to click into this spot. So that'll lock you up there. Now we don't want to be able to add in if we're on the road. And so what we're going to have to do is add to this if statement. So and greenfoot.getMouseInfo, and we don't see something under this. We don't see an object already there, because not only do we not want to add in a tower where there is another actor, is a road, but it is another actor in general. And so if we getMouseInfo.getActor and it does not equal null, then there is an actor already there, and then we'll add in another one. And so what we want to do is click, and whoops, actor needs to equal null, not equal null, because if we find that the mouse is over an actor, or excuse me, is not over an actor, if that equals nothing when we check if there's something underneath the mouse, then we can add in a new tower. Okay, so now we can add it in. We can't add it in on the road. We can't add it in when we go over another one. If we drag this off, nothing else came in. And so that is good to have. Okay, and so now we're able to add in the towers, but we also should only be able to add in a tower if we have a certain amount of money. Okay, we can have public static money equal 100 to start, and we can have each tower, we can say equal 50 to start as well. Public static int, whoops, so that'll never be a decimal. We'll just have integer value for money, and you'll start off with $100, and that will show up on the screen. And so we're going to go ahead and do show text of money, show text money at all the way to the right inside of the menu, probably right at the top. So if it's 720, we can subtract 120 from that and put it right at, let's put it at 630. 600 is the left side of a block. 630 will be right in the middle of a block, so that'll give us a little bit of a buffer. And we can go one block down, so we can put, let's do 30 down as well, because that'll actually be a half block down. So I'd put it right up at the top. And now we have money, and we need to scoot it over a little bit. But that can be our first row. It can tell us how much money we have. Okay, so we can actually, the x value is fine, or the y value is fine. The x value needs to be a little bit further over. Then we look, and we have our money. Okay, and so also our money needs to show our live amount of money. Okay, and so this can't just be in the prepare method, but also should be in the act method. So we're always live updating that money. So our money is 100. We could even make it an object. Probably would look nicer. We'll go ahead and do that. So create money. Actually, we'll create money display and say public money display. But we will set the image to a new Greenfoot image. And we know our Greenfoot images can be text, font size, color dot black, no quote there, black, and color dot white. Let's have our font size be 20 and our text say money. And surround that. There we go. Now when we drag in our money display, it looks a little bit cleaner. And actually we can create a third color that would be actually the background color. We can do a new color and have it be 0000. So then it will be a clear background. We're gonna copy, paste. Now, okay, so add in a parenthesis. So you got 3 close parentheses on here to close the new color, close the image, and then the set image. Now we're going to need to add in our money, and so we need a way to access our My World money, because since it's static, as long as we have any reference to My World, it'll know that since money is static and only shows up once, and you have only one value for it, that it can reference it just by calling on My World. And so we can go to money display and say My World game. You could say My World game. And then you do plus game dot money. And so now it knows that it can access the money, number money, from the My World class that we called game. So this will reference My World and money. So if we do money plus plus, we get rid of the show text here in a second, but we add in money. Money will show up and it'll add up. So we need to go into our show text, get rid of this, get rid of this, and then we need to add in the money object display a little bit bigger in the correct spot. So we're going to change this to about 50, and so that'll take up most of one set of cells right there. And then we can put some towers in and put them in the right spot. So this should be probably 30 for the Y, and let's see, 720 for the X, something like that. Yeah, 720 and 30 looks right. And so we can add object in level 1, and we're going to have this in every, no matter what level we're at, or if we've added, we're not putting it in the add towers method. And so we would put in add object money display. As of now, we don't need to have this referenced. Probably a good idea to reference it. 720 and 30. But for now we don't need to, so I'm going to be lazy and I'm not going to. So we'll see if we need it later. So now we have our money. Our money goes up way too fast, but we have it going. So the money plus plus we're going to get rid of. We'll go ahead and go to the next line here, and we'll say our money will equal minus equal, so we'll set our money equal to 50 less every time we buy a tower. So we're going to say, we're going to create a new variable and call it basic tower price equals 50. And then we will do minus basic tower price, just in case we want to change this later. And we will say also, if our money is greater than or equal to basic tower price, we will also be able to buy a tower, but our money is then going to get subtracted by basic tower price. So let's see this in action. We add in a tower, minus 50, added another tower, minus 50. We can't add any more basic towers in. So now I'm going to add in some enemies. So we'll make a class enemy and actually go ahead and give it an image. And we'll have the starting image. Let's have it be a spider. It's a pretty good size for it. When we add it in right there, it will go, and it needs to hit this, and this road location needs to turn right, and then this road location needs to turn left, and so on and so forth. So what we need to do is we need to have our roads have a few different constructors, as well as have it know when it's going straight. So those would be 1, and then we'd have we could have this be turn 90. This would be turn left. So let's have that be turn back to straight. And so you would just need to remember this. Sometimes might be why you want to create these as strings, because there's more options and you just don't have a list of numbers, but you actually have strings that you can define. But this will be fine. So the 2 will turn us down, the 3 will turn us back forward, which would be 0 degrees, and then the 2 will turn us 90, and then the 3 will turn us back straight, and then if we go up, we need to do a different number, so that will turn us, let's see, 270. So if to the right is 0, down 90, left 180, up is 270, so that's 4, and then 5 can turn us back all the way to the left 180. Okay, so now we have all different options. So 4 will turn us back up. We need to go back to the right, which was this 3 is pushing us to the right. And then we just need to remember these. And then 2 will push us back down. Okay, and then you can copy, paste, 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 paste. And we can change this to 2, 3, 4, and 5. This will allow us to have different roads, and we'll plug in a parameter for each one of these roads, just so we know which way we're going and what we're doing. So we need to have a parameter here saying that this road is Boolean straight. So this will say if the road's going to continue us going straight. We can actually copy and paste that. And then this will be int turn. And so a road with an integer value here will turn a certain amount of degrees. And so if we go back into our My World, now it expects all of these roads to either have a Boolean, true or false, or an integer value. So the first one will have a true, because it will be going straight. And then the 2 needs to turn us a number of degrees. Okay, so the 2 will turn us down 90. The 3 put us back to straight, so that's going to have actually a 0 in it. The 4 turned us let's see, where's the 4? Right here, so that'll turn us up, so that'll be 270. I know these are a little out of order, but you can make it work. And then this will be 180. So we have all 4 directions here, potential to turn. And then we need to set a value of turn. So public int turn, and we can have this dot turn equals turn. Okay, so after we create our turn, we're also going to want to create a Boolean for straight that we can save into this class. And so with our turn, we can just leave those as it is. So then with straight, we need to say this dot straight, which is the straight that we just added in up at the top that is available to the whole class. And we're going to set it equal to the straight Boolean that is available in our parameter here. So once we have that, we compile, we can go into our enemy, and we can start moving the enemy a little bit. So we're just going to have it move forward 3 to start, and we'll change that to a variable a little bit later. But we need our enemy to be able to detect each one of these road objects that we have all across our screen. And so we need to import a Java class, javautil.list, because the JDK that we have downloaded with Greenfoot allows us to access that list class and do a lot of different things with it. And so a list will detect an unknown number of objects in this case. And so it's kind of like an array, but you don't know how big the array will be because we have roads, but we don't know how many roads we're going to be detecting. And so our road that we're going to call is going to be road 90. And it's going to be if we're going to be turning from 0 degree turn to a 90 degree turn rotation. So we can do get, and if you control space, you can see get objects at offset. So if it's 0, 0, it'll just, once it hits it, it will start turning. We want it actually to be a little bit past where we would normally hit it. And so if you make it -20, our object might start reading it right here, but we want it to go a little bit past that. And since actually we're having 60 by 60 cells, it would make sense to have it -30 here. And then for our class, we're going to do road.class. And so that's what we're going to be detecting, semicolon there. And we are going to loop through all the roads. So roads. So these are all the roads that could be in our list. And it will be, we're going to kind of store those based off of the road 90 variable that we have here. So this will loop through all the road 90s that it finds. And essentially what we're doing is if our roads.straight is false, so we're at one of those roads that will turn, and we get our rotation, and that equals 0, we are going to set our new rotation to whatever our roads.turn is. So whenever we detect in this infinite listing, so this roads is detecting road 90, road 90, road 90, but we're going, remember, we're going past into the center of it. We will turn the parameter that we've plugged in for our new roads, each one of these spots. So if you remember, 2 was the first one, so that's turning us 90. That's why I've called it road 90. And it will set our rotation to roads.turn, and our roads.turn can be accessible because we've plugged in the parameter, we've set this equal, so this turn is equal to whatever this parameter is, and this parameter is plugged in here, and it's based off which number is plugged in our little multi-dimensional array map. Okay, so at 2, the new road parameter will be 90, which will make our spider detect it and turn 90. Okay, but we need to create a list for each one of these directions. And we're going to just switch up the numbers here a little bit. So our new list for going, let's say, 0 would be this would turn us back to the right, facing 0 degrees. So this is the number of degrees. So we come down, we face 0 degrees. So we want our Y value, we want to be able to go a little bit into this, about 30 pixels. So our Y value will be -30. Okay, so as we go, we want to push basically the center of our spider off by -30. And so we want to go a little bit past. Going down, we want it to be -30. And we want to make sure that this for loop matches the correct variable here, so that this new roads, these are named the same, but since they're both in for loops, they're different values in here. This is roads based off road 0, and this is roads based off road 90. And so if roads 0 is not straight, if it's false, and our rotation is, well, we're going to be going down on this one, so our rotation is 90, then we will turn still based off the roads parameter the same way. Then we go 180, and so we're trying to turn 180. It means we're turning to the left, so we're going up, and so our Y value will be need to be the 30, because this was going down, -30. This will be going up. Change this to 180. Your rotation will be 270, because you'll be facing up, and we'll turn along the road. Okay, and the last one is road. We're going to be turning 270 and turning 270. And so our value for our X, this one will be when we're coming back and we're going to be turning facing up. So it'll be going into the X value. So this will be the +30 here on the X value. Hit 270, hit 270, and our rotation before we actually execute the turn will be going left, which will be 180. Okay, and then if you save, compile that, and we add an enemy in, this enemy has the ability to detect road. Okay, it's going to be straight, straight. Okay, this is a turn. Which direction is it going to turn? Well, it's going to turn down because our rotation was 0, and we're finding the parameter that says turn 90 here. So we run it, turn, 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 and then you'll see that since we've done every direction and we've placed them in the correct spots, this will follow a path for us to reach the end of the screen. Okay, and that's all I'm going to do for this video. We're going to keep going into part 2, and we'll be adding in towers. Hopefully our towers will be able to fire at the enemies. We'll have different waves of creeps being able to come through, and you'll be able to add money as you add more, as you destroy more creeps. So hope you guys enjoyed. Make sure if you enjoyed the video that you hit the subscribe button so you don't miss the next one. And if you like the video, it'll help promote so others can see and find this video useful as well. So hope you guys enjoyed. Thanks.